Now, watch very closely. Don't pause the video. I'm going to put something up on the screen and I want you to look at it and see what you actually can divine from the moment that it's up there. So ready? That was pretty quick, but what you probably saw were colors. And that's because colors are pre-attentive for the human visual system, and they're used in integrated development environments to display different features of the code, different elements of the code. We're calling them components here, different components of the code. So we're going to talk about a little bit about all of these elements in the remainder of the lecture, and I want to mention that this color coding is called syntax highlighting. So it's because it's a program that's designed to recognize the pieces of the code, and you'll see we've got green, that's going to be comments. We've got blue, those are keywords. We've got this olive drab, and that's strings. Different integrated development environments will by default use different coloring, but they will color all of these elements in some way. So we use the term variable when we're talking about add.py. You set a equal to the integer conversion of the first user argument. You did that using an equal sign. So formally, a variable is a name that represents a value. It's bound to the value. The value is strictly not stored in the variable. It just refers to or points to a value that's stored somewhere in memory. But that's a Python nuance. So what you really need to understand is that when you do an assignment statement, you're going to put an expression on the right and a variable name on the left. So an expression is a value. It can be a number or a string or some other things that we'll talk about later. A code statement is an instruction. Do something, change something, print something, set a variable to a value. An assignment statement is the name for a statement that sets the value of a variable. So this example on the right shows the variable name is on the left side of the equal sign, the value is on the right side of the equal sign. So back when we were talking about the requirements for the course, I said that you need to write your name and your Unity ID in the script. And that can be done using code comments. Code comments are code that the Python interpreter just ignores, but they're only there for human readers so that we can either know how to run the code, know who ran the code, or know who wrote the code, how it was modified, what are the pieces of the code doing. So we use the header documentation, we use comments in the very top of the script to specify the name and the purpose, the usage, which means how do you run this, what kind of thing do I need as user input. This one takes a field name, and example input is good to have, so it can say, you know, an example of a field name, and what kind of output to expect, who wrote the script, and so forth. And the body comments can say what the code is doing. You only need to really use comments in places where the code itself is not self-explanatory. But comments can be a good way to start writing, because you can write the what needs to happen in the script before you actually figure out how the details about how to make that happen. And we call that pseudocode, which we'll get back to in a little bit, another lesson. So I mentioned that the blue elements in the code were Python keywords. These are words that have special meaning in Python. So You can't use these keywords as variable names. Python will not accept it. It'll say it's a syntax error. Like if you look on the list, exec is one of the Python keywords, and that is an assignment statement trying to set exec to this executable, but it fails. It gives you a syntax error. So this is a complete list of the keywords in Python at this point. Notice that all of these are lowercase. They have to be used in lowercase. Python is case sensitive, so if you want to use the if keyword, you have to use both lowercase, not either of those other case configurations. Now, in our add.py exercise, we saw one of the standard modules in Python. That was the sys module, which stands for system. A standard module is, well, first of all, a module is a set of related code, and Python has a set of standard modules that are automatically installed with when Python is installed itself. Some examples are the math module, OS, the sys module, shutils, winsound, time. When you import a module, then you are able to use it. So if you want to use the sys module, you have to import it before using it, and you have to use this import keyword. It can be used in a bunch of different ways, but usually we'll just say import and then comma separated list of the things that we want to import. After you import the module, then you can use dot notation. And we mean that literally, the dot that comes after the module and before a function name or a property name, that's called dot notation. So module name dot function name parentheses arguments. As an example, there's a module called the math module, and you can say math dot radians of 180, and you can see that that's output is a conversion of 180 degrees to radians. As another example, we use the argv, the argument vector property from the sys module. We said import sys and sys.argv. Then we will also be using the OS module, which stands for operating system, and there's a listdir function in there, which will list all the files in a directory. The dot notation in this example, math is the module name and radians is the function name. There are some rules for naming variables. They are case sensitive, just like keywords are case sensitive. So if you make a variable named freeways and it's all lowercase, that can be a separate variable from the one named freeways with the uppercase F at the front. Probably not advisable to do because you're going to end up with some confusing code, but usually the case sensitivity comes up when you forget that you've used a certain capitalization and you use the variable with a different capitalization later in the code, and it says that that variable is not defined, and it isn't because it's a different case from the one that is defined. So you want to avoid using special characters like slashes, ampersands, percents, and so forth in variable names. And variable names cannot start with numbers. They can include numbers in them, but they can't start with them. And for case conventions, we like to use lower camel case, which is the first. If you have words, more than one word in your variable, you can put them together without any underscores in between them. You can't have spaces in a variable name, but you can have underscores. But you can also just put the words together and use lower camel case to capitalize each word that's inside of there. So lower camel case is the first whole word is lowercase, and the next two words, or next words that come after that, one or more words, has an uppercase for the first letter. Here's an example of a lower camel case variable. If you have an acronym at the beginning of your variable, use lowercase letters for the acronym. If it comes at the end or middle, use all uppercase letters. When practical, use descriptive variable names. So, but it's not always practical to use the whole name. So practical, it's practical to use side instead of S, because side is a little bit more informative than what does S stand for. An SA, square, area, and side times side is more clear than SA equals S times S. The star means multiplication. But you know, sometimes things are difficult to spell, and if we set that, we're going to have to be using that all the time. So like the hypotenuse, maybe you don't want to use that entire word, because it's a lot to type out and you may spell it wrong in the meantime. So indentation is important in Python. It's meaningful in Python. So there are blocks that will be blocks of related code that you group together by indenting them the same amount. In other programming languages, curly braces or keywords are used to start and end blocks of code. But in Python, those are not used. You just have to use indentation. And the integrated development environment will help you with indentation. So in this example, we're looping through, we're repeating through a bunch of steps, and those are all indented to the same level, except the ones that are inside that are related blocks of code. So this is another indented repetition. We're going through every letter in a word inside of the loop that's going through every word in a list. And then there's another level of indentation for this conditional statement, where the condition is if the letter is a vowel, if it's in the vowel list, then do something. So now the other thing I wanted to point out is that Python Win and other IDEs will have the ability to turn on white space. White space is the places where there are just spaces and no other characters. So they could be individual spaces or tabs. And sometimes if you take your code from PowerPoint or from HTML, you may find that you paste it and you get these squiggly red lines and you can't figure out what that's about. If you view the white space, you'll see that there's an inconsistency in the spacing, that there are spaces and then there's space. Here's a space with a tab bar. That's what this arrow is representing. So what we would do to clear out this issue, which is not going to let us run the code because it thinks there's an error in it, we would backspace it up to the next line, hit return, and then our spacing will be corrected, because the IDE automatically puts the code indented to the layer of the previous line of code with the correct white space. Now, Python is full of objects. Everything in Python is an object. Objects have several properties. They have a value, they have an identity, and a type. So in the example over here, we have a variable that we're setting called river, and we're setting that equal to the string Arno. So when we print out river, we get Arno. We don't have to, remember, we don't have to use a print statement. We can just put the variable there and hit return. We can also find out what the ID of this is by putting ID in front of the variable and putting it in parentheses and hit return. And that, so if you try this on your own computer, you may get different values because, well, you most likely will get a different value because this number is generated based on where the information is being stored in memory. And then the third thing that you have is a type. So what's the data type of a variable? It's the kind of a value that the object holds. And it dictates what operations are going to be allowed for that object. So we can say type and put parentheses with river inside, and it tells us type is str, which stands for string. We'll go over strings in a little bit. Now, there's something special about Python that's good and bad. It has something called dynamic typing. You can take a variable that you've already been using and set it to another value of a different type. 96 is an integer type, whereas Arno, because it has quotes around it, is a string type. And if we say river equals 96 and find the type again, we're going to get integer. So the type has just changed because we changed the assigned value. This is called dynamic typing. Dynamic means changeable. So on the previous slide, you may have noticed that we used type with parentheses and ID with parentheses. Those are two examples of Python built-in functions. Python has a number of built-in functions that are always available that you can just call without importing any modules. And here's a list of them in alphabetical order. You can also get a list of built-ins, including exceptions and constants, as well as functions, by using this code in the Python Win interactor window. You can say dir parentheses and then 2 underscores on the left, followed by built-ins, and two more underscores on the right, and you will get this list of all of these built-ins. So one thing to remember about built-ins is you do not want to use them as variable names. Unlike when you use keywords as variable names, Python will not complain about built-ins being used as variable names, unless you then try to use it for its original purpose, in which case it will no longer work because you will have changed it to be something else. So functions are groups of related code that perform a specific task. So an example of a function that does mathematical stuff is the round function. So you can say round 1.7 and it prints 2.0. Another example is the min function. That stands for minimum. If you give it a set of numbers, here we just said 1, 2, 3, it knows that 1 is the smallest one. So, as we mentioned on the previous slide, there are a set of built-in functions, and these come along with Python. Later on in the course, you'll learn how to define your own functions. And another terminology that's used with functions is calling functions. A code statement that invokes a function is calling the function. So for example, we would say we called the round function and then we called the min function. And that's just saying we wrote in our code a statement that uses that function. We can pass in arguments for the function, and those are providing information that the function needs in order to run. If you want to call the round function, you have to pass in a number to be rounded. What number do you want me to round? It'll say if you don't pass anything in. So those are the numbers. Those are numbers or other kinds of values that you put in parentheses behind the name of the function. Then we have the return value. Some functions have an informative return value. Other functions return none, which means they're returning nothing. The round function on the top of the slide returned a 2, and the min function returned a 1. The help function doesn't return anything, it just prints something. So not all functions have to return something. Sometimes I like to draw a comparison between a butler and a function. You call the butler and specify the arguments, and the butler brings something back or does something for you. So if you call the make tea function, the butler will make the tea based on your arguments. Did you tell them, butler, that you want green tea or black tea? Then the butler will bring that kind of tea and return it to you. Now you may also have a request to the butler that doesn't involve returning anything. So you may call the dim lights function. And in that case, the butler will dim the lights, but he's not going to bring anything back to you. So the help function is one of the built-in functions, and that function prints a template, which we also call a signature, which is the blueprint for how the function's to be called. The arrow that you see in the template points to whatever value will be returned. Let's look at that a little bit more closely. So the signature itself has a list of parameters. So we talk about parameters or arguments. I've been using the term argument because we were talking about the specific values that were being passed in, like 1.7 is an argument, whereas the parameter itself is the kind of information that's to be passed into the function. So here the parameter is specified as a number. Here's the blueprint, the signature for how to call the function, and here's the list of parameters. Notice that we only called it with one number. You can call it with one or more numbers because there's an optional parameter here that is there to specify the number of digits you want the number to be rounded off to. By default, it doesn't give you any digits behind the decimal. So an argument is an expression being passed into a function, a specific expression. So the arguments here are 1.7 and 1, 2, and 3. So we've Now we've finished talking about built-in functions for the moment. Let's move on to another built-in Python component, which is constants. Constants are there for special kinds of values. They are assigned as soon as Python is launched, and the constants that we'll be using are true, false, and none. These variables, we only use them, we don't try to change them. So if you call the type function for true, you put true inside of the type function, you'll get type bool, which stands for boolean, which is true or false kinds of things. If you print true, it returns true. We'll see that when we're doing geoprocessing, we'll use true or false to set the overwrite output variable, which will allow us to overwrite existing data. Another kind of built-in that Python comes with is exceptions. These are common errors that Python can identify automatically. So an exception is thrown when one of these errors is detected. We call it thrown. You can catch it, as we'll see later, but we won't get into that now. When an exception is thrown, a traceback message is generated and printed in the interactive window. And this traces the code that led to the error. So the bad script that has an error, an exception in it, will stop running when an exception is printed. And some examples of types of exceptions are syntax error, type error, name error, and so forth. And we'll get into the details of built-in exceptions a little later when we talk about how to handle those within the code. We have another exercise to try. And the idea of this is to use Python Win to learn how to execute single lines of code interactively. In this exercise, you'll call functions, you'll throw some exceptions, you'll write some code that will throw exceptions. You'll type each line of code, each code statement, one at a time in the interactive window. Before running each statement, try to predict the results. Select return or enter to run each line of code. So you type it in, you hit return or enter, whichever your keyboard has, and then see how accurate your predictions were and see if you can figure out if you made any mistakes, why you were wrong and what it's actually doing. So welcome back. Hopefully by now you've gotten a chance to try the try me exercise and predict what would happen for each code statement. So let's go over to the try me exercise, and I'll show you how you might arrange your windows so that you can see both at the same time. You know, some people don't like to type everything. They may want to just copy and paste, and that's okay. So I'll put this one over here, and I can Control A and delete and clean up my interactive window to start with. Now, one line of code at a time. If you try to do more than one line of code at a time, it's not going to work. See this line of code, how blue that is? That is not going to be executed. In fact, the round wasn't even executed. So we needed to copy and paste or type one line of code at a time. And one thing that you're not seeing, but I'm seeing on my other screen, is that when I typed this first parenthesis, I got a help statement for the round function, what told me the signature and what it returns. So when I do that, I get a 3, and if I do this statement, I get a 3 because it rounds up for numbers 0.5 or greater. And if I do the next statement, I'm doing an assignment. So now when I print x, what do you think x is going to, what do you think will be printed? Hopefully you said 3. And if I just say x, that also prints 3. If I look at the help, I call the built-in help function. I get the signature and a little bit of an explanation about what the round function does, how it behaves. I can type, find the type of quote 5 unquote, and that is a string because we put quotation marks around it. Oops. If I call help for the int function, I find that int is a built-in function and has a very long explanation for what it does. Looks like you can do different bases. The default is base 10, which I hadn't noticed that before. Here's all the rules. What happens if a number, if x is not a number, then it's going to give you trouble. But it does enable you to print or to convert things that are strings with numbers inside of them. If I try to convert foo, which can't be converted to number, I get a value error. So now let's try our next statement. Oops, input data over here. So this is doing an assignment. And this is doing an assignment statement. If I say type FID, I get integer, which is what I expected because I set it equal to 145. If I say type FID all lowercase, what's going to happen? It gives me a name error because lowercase FID is not defined. So if I set average equal to 92 and find the type of average, what's it going to be? Yep, integer. If I set average equal to A and find the type of A, and sorry, find the type of average, it's a string. Now, if I do an assignment statement, print equals input data, did you predict correctly what's going to happen? Ooh, syntax error. Why? Because print is a Python keyword. If I do, we did this example already. Let me do another example. 5, 2, and 34. This should print what number? 2. Yes, 2. That's the minimum of the 3 numbers. Oh, you can type any number of numbers. 6, 1, 4, 1, 4, 2.4. They can be decimal. Those are called floats. Still 2 is the smallest one in that example. Okay, now if we say type min, did you predict what that was going to say? It's a min is one of our built-in functions. So it says built-in function or method. And scroll down a little bit more, we're almost done. And what about hi in hi ho? It prints true because it found the string hi as a substring of hi ho. And if we type we type min equals 5, back up to here, min equals 5, and then we try one of our previous statements. Ooh, how did I do that? I did control arrow up. So you can see control arrow up. We did this a few minutes ago. It gave us 2. What's it going to give us now? 2? No. It's a type error because we just dynamically updated the type of min. We changed it from a built-in function to an integer. So this says type error, integer object is not callable. We can't call the min function anymore because it's no longer defined as a function. It is defined as an integer. And if we say the type of false, we get bool, which stands for boolean. And if we say dir double underscore built-ins underscore double underscore, we get a list of all those built-in functions. How accurate were your predictions? Hope you did well, or learned something at least. The take-home messages were variable names are case sensitive. Python dynamically changes the data type when you assign values to variables. Don't use keywords or built-ins as variable names. And here's the example that we had, which was we said type min, built-in function, and we used it. Then we set min equal to 5. Then we tried to use it again, and the type, we got a type error because it's an integer. It's now an integer. This lesson discussed why we're using Python for the class, how to use some integrated development environments and what are the advantages. You learned how to pass arguments into a script using Python Win with the click on the running man and use the little box next to that says arguments next to it, and that those get passed into the script and you can use them by using the sys module and the argv, the argument vector property under the sys module. The Python code components that we went over are listed here. And the next thing that we're going to do in the next lecture is talk about these data structures, the built-in data types that we'll be using a lot throughout the remainder of the course. There are a few additional topics that are listed in the appendix slides in this slide set that we won't go over, but they're related to what we did today.